Let's see the problems on PDF, probability density function, and CDF, the cumulative distribution function. So here the problem is, we know what is PDF and CDF. So let's solve some more problems so that we can solve any question if it comes. The probability density function of a random variable x is given by f of x is equal to x into e raised to minus x into u of x. Then determine CDF, the cumulative distribution function. Evaluate the probability if x is less than 1, less than or equal to 1, and even find the probability density function when x is in between 1 and 2 and when it is greater than 2. So these kind of problems are there in the question paper. Let's see how to solve this. We know the relation between the CDF, the cumulative distribution function. CDF is represented by capital F, and PDF, the probability density function, is represented by small f. Now, in order to find the probability density function over a limit, if like x is less than or greater than, if some such kind of problems are there, we need the CDF. So to get the CDF, we know the relation between the CDF and PDF. That is, the CDF is equal to integration of PDF. So integration runs from minus infinity to x. So 0 to x, fx of x dx it is. So fx of x is nothing but x into e raised to minus x. Let's substitute and integrate. So this minus infinity to x goes to 0 because it is multiplied with u of x. So u of x starts from 0 and ends at infinity. So this minus infinity will not be there. Our integration will be from 0 to x. Then for this, x into e raised to minus x has to be integrated by parts. So when we do this x, e raised to minus x is integration e raised to minus x divided by minus 1, and again the integration of this value e raised to minus x of minus 1 into 1 and integration of this factor, that is dx. So when we solve this, we are getting this value. Now in this value, if PDF x less than 1 is to be calculated, then p x less than x1. So our x1 is 1. So p x less than p of x less than or equal to x1 is given by fx of x1. So we find this one by putting x is equal to 1. Even though it is less than, we put 1 only. So let's find this value when x is equal to 1. So when x is equal to 1, this works out to be this one, e to the power minus 1. So it is 0.264. Similarly, if it is p of 1, p of x in between 1 and 2, if we are finding, then p of x less than or equal to 2, it is fx of 2, the highest limit, minus the fx of 1. So to find that one, fx p of x in between 1 and 2 is fx of 2 minus fx of 1. So we need the values of fx of 2 and fx of 1. So to get those, let's substitute p of x less than or equal to 2 means we have to put x is equal to 2 in this equation, whichever we have solved it for. So when we substitute x as 2, we get it as around 0.94 in this equation. And similarly, when we substitute 1, already the value is there with us. We substitute, so it is this value minus the earlier one, which is this one. And similarly, for x greater than 2, we have to substitute 2. So we have to put 2. So that is p of x greater than 2 means it is the value which we have found it for PDF when x is 2, that is 0.594, and for x greater than 2 means up till 2. We know that up till 2, whatever is the value. So let's say this is 2. So there will be a 0 and a minus sign on this side. So up to 2, whatever is the distribution, we don't mind. But after 2, what will be the, we know that the total integration of minus infinity to plus infinity, that is fx of x, it is 1. Means total probability is always equal to fx of x is equal to 1. So subtract 1 so that for greater than, subtract 1 so that for greater than 2 will find. So what is the probability distribution? It has to be this 1 minus whatever is the rest. So that is 1 minus p of x is equal to 2. So if x is less than or equal to 2, whatever is the value, 1 minus subtraction of that value. So when we do that, we are getting, it is 1 minus 0.594 is equal to 0.406. The next problem is this one. Suppose if a random variable has its CDF as fx of x is equal to this 0 when x is less than 0, and if it is a k into x square when x is in between 0 and 10, and it is 100k for x greater than 10. So evaluate k. First we need to find what is the value of this k. Find the values of p of x less than or equal to 5, and when p is in between 5 and 7. So to find this one, what should be done? Here we need to find the value of k first. The problem says that these are the values, but from the definition we know that x is less than 0 means its value is 0. So let's draw the CDF function fx of x. The CDF function fx of x is it is 0 and it is having some sort of distribution, we don't know the nature, and here it is 100k. Let's say 100k is in this way, 100 into k. K has to be a constant, means it has to be a constant. But from the knowledge of CDF, we know that whatever may be the distribution, the CDF may go in increasing in a stepwise, or it may take up any kind of such kind of a form, but it's going to be 1 at the last. So its value would be 1 when we cross up all the values of its possible outcomes. So from that we have to write that 100k is equal to 1. So as 100k is equal to 1, k is equal to 1 by 100. That's it. So that is the first value of r, that is the value of k. So once we know the value of k, then we go for finding the further things. So k is 1 divided by 100. Once k is found, we substitute the upper value. We substitute it in the limit x and when it is in between 0 to 10. So it is k into x square. So k into x square, for that x square divided by 100, in between 0 to 10 it is. So p of x when x is less than 5, less than or equal to 5, then it is fx of x is equal to p of x less than x. That is, this value already we have is k into x square. So let's substitute. So p of x less than or equal to x means 1 by 100. 1 by 100 into x square is its value in between 0 to 10. So just write x as 5. So when we put x is equal to 5, so it is 5 square from the definition itself. So we get 1 by 4. And similarly, to get p of this probability in between 5 and 7, it is p of 7 fx of 7 minus fx of 5. So fx of 7 minus fx of 5, which is 7 square by 100 minus 5 square by 100, will get. So similarly, one can solve such kind of problems. I hope you solve the rest of the problems, and let me know if any difficulty or confusion in solving these is there.